Hello, my name is Matthew Vale.
Hi, my name is Shuangyi Zhang. This is our project, Spaghetti Production. And as you see here, our aim is to develop a fast spaghetti production process. And this production is aimed for student-run plant. So our objective is to produce 300 kilograms of pasta per hour, and this is a plant that's going to be run 22 hours a day and 365 every year.
Going into the market section, since we're doing this plant in the United States, we took a survey of American adults and we found that 82% of American households eat and have dry prepackaged pasta. And that's because it's very easy to consume, very convenient, low cost, and it covers all age ranges, but we found that most people within the ages of 15 to 50 eat it. So going into the background, we covered two main sections of extrusion and drying. The extrusion process is when the dough is being fed through and being pushed by pressure through the die and punching it out into the shapes of our spaghetti. And then the dryer dries the pasta down to our ideal moisture content of 12%.
And we have a couple alternative solutions for each of our unit operation. And here you can see our three mixers. One of the alternative is to have a continuous process which contain 5 mixers run for 16 minutes, and also a extruder which have 2 extruder line. And also we can have different dryers. Here in our case we're using a tunnel conveyor belt dryer, but in our alternative, we can use different ones and have different setting, different temperature setting and relative humidity settings. And
so just to give the basic layout of our production process, we start with our raw materials, which we get from our storage tank, mostly the semolina and the water. Then those go into the mixer where the dry ingredients are mixed together in addition with the water that hydrates it. That mixed dough gets pushed into the extruder, and that gives us the shape of our pasta into the spaghetti. And then our dryer is broken up into 7 sections, all of which have different relative humidities and different temperatures. And after it goes through the 7-stage drying process, it goes into packaging, storage, and shipping.
And here is a chart to show our plant design of each of the unit that we're including in our process line. And over here is a lab scale experiment that we performed in lab. And we prepared a flat sheet of pasta due to the, because it's easier to measure the, the surface area. And so that's why we choose flat sheet pasta instead of the spaghetti. And we measure we run it at first, we run it at 40 degree and 80% relative humidity until it reach equilibrium. We switch to 80 degrees Celsius and again 80% relative humidity. Over here, the 2 graphs are the moisture content change within time and the weight change within time. The blue line is the weight, and the red dot line is the moisture content. And over here is a 40 degree 80%, and here is the 80 degree 80%. Then we measure the shrinkage, which showed over here. You can read from the data, there is a huge shrinkage of the pasta sheets. Then we did an optimization which aimed to find the best size of our dryer and fan. So we can use the minimum cost of, we can design a dryer and fan that have a minimum cost, which is over here at this point, gives a minimum total cost. The blue line is the operating cost of both dryer and fan. And the red line is fixed cost of both dryer and fan. So this gives the minimum.
finally, going into the economics portion of our project, the three main things we focused on were finding our total capital investment, our total product cost, and our return on investment. So the total capital investment, that was based on our purchasing equipment, and the total product cost is based on our calculations of the raw materials. And finally, our return on investment is calculated based on our estimation with our straight line estimation based on its 10-year life.